Hello to everyone. I'm Alex Correa, General Manager for Graphene, and I'd like to welcome you all to this new program for Graphene Talks. This is a program for us to expand and share our knowledge on graphene and its applications collaboratively with key stakeholders from the industry and universities. Our objective today is to share the latest news, trends, and market potential with this fantastic new material, which is graphene. Each month we'll host a new guest, which will bring to us their unique look into this material and the disruptions it's bringing to our businesses, markets, and life. And it's an honor to have with me today James Baker, CEO at Graphene at Manchester University. So James, it's great to have you here with us. Thank you for joining, sharing a bit of your great knowledge on the topic.
No problem. Delighted to be here today. Thank you.
Great, thank you. And I think the first question is to ask you, why is Manchester being known as a graphene city? What's happening around the city? What's its connection to material? How is it changing the landscape?
Thanks, Alex. Yeah, so first of all, people may have heard the story by now, but graphene 2004, two scientists in Manchester, driven by curiosity, took some sticky tape, some Scotch tape and some graphite. And if you peel that over and over, probably around 17 times is the optimum, you can isolate a single atomic layer of carbon. So what is graphene? It's got length, it's got breadth, but at one atomic layer thick, it's the thinnest possible material, and it's called graphene. So what? They then got the Nobel Prize for Physics in 2010, not just for that discovery, but as a two-dimensional material, graphene has these unique and wonderful properties. So first of all, Manchester is the home of graphene, where it all started. But Graphene City really came about because what we're trying to achieve is not just the science, but the conversion of that science into products and applications through working with industry. So if you like, we're trying to copy a little bit from Silicon Valley, but what we really want to do is to create the partnerships with industry, whether it's people making graphene, using graphene like Godow, or end users, to really create that ecosystem of academics and industry to accelerate the benefits of graphene into the marketplace.
Fantastic. It's very, very nice to hear. And how is the geek position in this whole disruption that you're causing? Right? What is its function? How's it connected back to the Manchester University and to the city itself? Right?
Yeah, so it's really challenging. If you look at history of new materials, it can take many years from discovery in universities through to products and applications. So in Manchester, first of all, we have something called the National Graphene Institute, which is really about the science, not just graphene, but today we look at over 100 other 2D materials. So lots of science, lots of discovery, lots of new materials. But when you look at history, it's often difficult to convert that science into products and applications. So Manchester was also fortunate to have a second facility called the Graphene Engineering Innovation Centre. We call it the GEEK, which is really about that rapid translation of the science into pilot production and initial scale-up working with industry. So it's our second facility in Manchester. It's very much around the translation of the science, not the pure science, but it's really trying to fill that gap, often called the valley of death, between academia and industry to accelerate the adoption of these new materials like graphene and de-risking it, so that companies like Godow can hopefully take them forward into their products and applications.
Great. And if a company would like to join this ecosystem or join the geek, right? How does it work? How does the tier system work? What's the difference between each tier, and how can we partner with you guys?
So it was really interesting. I come from industry, and I've worked with universities in the past, and often universities are quite difficult to work with. Sometimes they're quite bureaucratic, quite slow. And it can take some time, particularly when it comes to areas like intellectual property. So what we've done with the Geek is develop a tiered system, a bit like joining the gym. You can become a tier 1 member, which is our premium membership, which Godow are involved in. But there's also lower entries, what we call tier 2. And one feature of the Geek is that any intellectual property that we develop, any foreground IP in the Geek, is owned by industry, but you can join as a member, which entitles you to do projects, to use equipment, to have space. Because what we're really trying to get is that really strong mixture of academia with engineers, with industry, and to bring that together in a unique way. So we've formed a sort of a membership model, delighted to have Godow as a tier 1, but part of our model isn't just geek talking to partners. We want partners to talk to each other and hopefully build collaborations to accelerate these ideas and concepts into the marketplace.
Right. And how is this say interaction between different members of the ecosystem, potentially the competitors or partners? How is this day to day? How does it work? Right? How do you guys help this interaction to really collaborate to future graphene?
So it's a really good question. I'm a strong component of what we call open innovation, to encourage people to collaborate, encourage people to partner. At the same time, we've got to respect confidentiality, because we could have competitors, we could have competing businesses. So the Geek is laid on 3 floors as a building. On the ground floor is where we do all of our project work. So that's generally behind a locked door, working with a specific partner. But it's not an open area where people can walk through and just see what's going on, or look at a machine, or try and observe what somebody else might be doing. So the ground floor is very confidential. People can go there, but it's quite a controlled environment. On the first floor, again, we have industry labs where industry can work in a controlled way. So again, locked doors, only Gerdau employees, for example, will be in your own lab. But then on the second floor, which is more office space, open plan, we have areas where we encourage people to collaborate, to talk. Maybe it's over the coffee bar, maybe it's in a meeting room, maybe it's at a conference. So we're really trying to facilitate discussion taking place, but absolutely respecting confidentiality when it comes down to project work. So it's a balance. If you want total confidentiality, you would lock yourself in a closed room and not talk to anybody else. We enable that, but what we really want is people to come out the room at break time or at lunchtime, or when they're not doing their projects, to hopefully talk with the other partners around the Geek. And that's been challenging over the last 18 months because of COVID. But actually, I think we've got more conversations going now through a mixture of Zoom and Teams and other events. So really going forward, we're trying to encourage people to do actual networking, as well as an increase in events like today, where we can talk through webinars and hopefully communicate to a broader audience as well.
That's great. If I hear from my team, is really this last floor is where the sparks really happen, right? I think where the good ideas and the good collaboration work starts, and then hopefully from there it becomes something we can really bring to the market, right, in terms of.
You bring great knowledge also. So working with companies like Gerdau is really important to us. We have a lot of knowledge in material science, in graphene, in 2D materials, but we don't always understand the market drivers or the challenges in your marketplace. So for me, that conversation, as well as hopefully you learning from us, is us learning from you in terms of market challenges or issues or problems in the real marketplace. And that's what we're really trying to encourage, not just what we would call technology push. We want to get more market pull. So graphene meeting real challenges, real problems in the marketplace, which typically come from organizations like yourself, who have people who are at the front line, talking to customers, talking to markets, understanding those different drivers. And that's very key towards our model.
Right. I've heard it more and more these last months, really, that graphene now is a tipping point where it's really about having the market push, right? That's what say the material needs, or the whole supply chain to make this material really relevant to the market needs, right? And our personal feeling, like yours, it's all about open collaboration, open innovation. I think there's still enough room for the market, for the whole community, and there's still enough hurdles that have to be easier to fight if we're working together than working as competitors, right? So I agree. It's always a challenge to get the mindset sometimes.
And I applaud Gerdau. I think I've recently blogged around, we are closing to an inflection point, tipping point. If you look 17 years from 2004, is still quite young for a new material. But increasingly, and already with Gerdau, we're seeing some of those early, hopefully quick wins. And we're not talking about products that are 5-10 years away. We're talking about products that are 6-12 months away. I think you're going to see a real inflection point over the coming period, where we see an increase in pace of those products hitting the marketplace. But we need engagement, and that's what's great to see with Gerdau and through Gerdau Graphene. I think we're now at a point where we can start to see that supply chain and exploitation really starting to kick in. So excited for the next period, really.
Okay. And how would be a typical day at the lab? So, for example, teams, how do they work? How do they collaborate? How's the day-to-day activities? Say before COVID, right? I think as you said, something changed a little bit. Now hopefully getting back to a more normal rate. But how would that be for the team?
I think one of the things that excites me most about graphene is very hard to answer that question because there is no typical day. One day we may be talking about composites and rubbers. Another day it might be around batteries and supercapacitors. Another day it might be around an ink or a formulation or a wearable device. So from a technology side, we're working in many different sectors, many different applications. In terms of the laboratories, post-COVID, I'm only there for a couple of days a week. But when we go there, typically we are trying to get that collaboration we talked earlier. So it may involve conversations with partners, it may brainstorming, chats on the coffee bar. What we're really trying to do, though, is to increase the pace of that innovation cycle. So what we don't want to be doing is just having lots of meetings and lots of discussions. Our model ideally is the geek can have a meeting or a discussion on Zoom or in a meeting room. We can then go downstairs to make something, to test something, and get a result quite quickly. So hopefully when you come to the geek, you see things happening at a real pace. A really good example recently is we've laid a concrete floor. This is all happening over a few weeks and months and gone from a little bit of lab work through to laying a 100 cubic meters of concrete, a graphene concrete, in probably around a 6 to 12 week period. So things happen quite quickly. Sometimes we fail. And as a culture, we want to encourage failure, not failure for failure's sake, but failure is often a point of learning. So if we can do something quick and learn, overall, we can hopefully save costs, save time, and improve a product to market. So quite a difficult question to answer that. Every day is different. We're often on Zoom. What's great about the post-COVID world is we can be talking to Brazil, we can be talking to UK, we can be talking to Abu Dhabi in the same day. Exactly. Whereas normally we're probably on a plane for many periods of time, whereas generally now we're quite effective around not having to travel, but we need the labs open, we need the labs operational to really do that experimental work, which is core to our model going forward.
For sure. You talked a lot about concrete as an example. Last week we had a very good conference with the PhD students in the area, basically Manchester, Lancaster, and Cambridge. And one of the questions they asked us was, what do we see as the initial, let's say, very commercial products we see with graphene? I'm sure there's still already products on the market we know of with graphene, but how do you see really the very big volume drivers? What do you see happening in the next coming months in terms of application?
I think one of the things that's helping us to answer that question is the drive towards sustainability. And certainly in the UK and around the world, there's this drive towards a more sustainable future. And as a general statement, less of graphene is more. And what I mean by that is, first of all, you only need a very small amount of graphene when you're adding it to a rubber or a concrete or a plastic. And secondly, you can potentially use a lot less material. So concrete is an example. For equivalent performance, we're using up to 30 to 50% less concrete. So really is less concrete, less material, less CO2. So I think the near-term applications will be driven by taking material out. So maybe it's a rubber product, shoes, footwear, where again, you can reduce the amount of rubber for equivalent performance. Concrete, I think, could take off quite quickly around what I would call simple applications. I don't think we're quite ready to build a high-rise building yet, probably because of risk. But for example, we did the floor of a gymnasium. We're in dialogue around doing some similar type of structures, but not for high-rise building, but simple concrete or structural buildings, I think could move very quickly, and that would really drive volume and demand very, very quickly. If you look at the amount of concrete that's poured around the globe, you're talking a significant quantity, and that could have a real impact on reduction in CO2. So I think it's going to be around where graphene is an additive. So it's graphene into rubbers, graphene into concretes, graphene into plastics to reduce the amount of material and improve the overall cost and performance of that product. Well, probably where you'll get the initial demand. And already you're starting to see a few examples in the marketplace where that's starting to happen. The ones where I'd really like to explore with yourselves are things like automotive. If we can really get into the automotive market, then that could be really huge in terms of volume and demand. And that would be really exciting for many of the stakeholders involved in graphene.
Sure. And I think one thing that's interesting is we have such a diverse public going to the geek, right? We see people going from the government, from company leaders, key researchers, right? So several, even the Nobel laureate is mentioned are always there, right? So it's a very diverse public. I think. How is it dealing with the different types of views on the material, different types of approaches, right, to the application? Any funny stories we can share? Interesting stories of all this interaction. We probably see that every day, so it might be quite interesting, quite unique.
One of the great things about working with universities, you have very different characters driven by different motivations. The two Nobel laureates are still very active in graphene. Yeah. Again, not many people know, but a few people know that Andre Geim is one of the few people with 2 Nobel Prizes, as well as a Nobel Prize for graphene. He has something called the Ig Nobel Prize. Okay. That's for levitating frogs. So before graphene, if you see Andre, you might see a few floating frogs around his laboratory. Okay. I think one of the best things that I like, though, about the Manchester culture is, graphene was actually isolated, not by a commercial reason. It was driven by curiosity at the time. Literally they did take the sticky tape out of a bin and then peeled it, like I explained earlier. So it was curiosity. Yeah. But even today, the university and the graphene group promotes what they call a Fun Friday, where the academics are given a little bit of permission to do something a bit different, a bit exciting, something that's not necessarily driven by their day job, but more curiosity driven. And one of the famous ones that I relate to, and for me it was a great story, is, and again you can Google this and look it up. On one of the Fridays, graphene has a property as a membrane where you can actually separate, potentially for drinking water, you could get dirty, salty, contaminated water through a graphene membrane into drinking water. And on a Fun Friday, one of the academics decided to take a bottle of whiskey and he put it through the whiskey through a graphene membrane to create a colorless liquid. So he effectively took the color out of whiskey. Now, why you would do that, but again, you can Google this, I didn't have this prepared. I actually got a graphene membrane into a small device like this. We had a visit to America, Washington, a couple of years ago, just before lockdown. And I actually in Capitol Hill took some bourbon in a filter and took the color out of bourbon. Why you would do that? If we could actually take water and convert it into whiskey, we'd be doing really well. But what it's really demonstrated is that graphene can select the small colored particles to remove those to make a colorless liquid. So again, it's a little bit of fun, but it was actually quite a serious experiment that showed how graphene could take particles out or contamination out of a liquid. So Fun Fridays go every Friday. There is a seminar every Friday afternoon. And again, you get lots of silly stories like that sometimes are quite funny, but do have a serious part to them in terms of understanding what graphene may or may not be able to do.
Great stories and a lot of science behind them too. So very good. And I think of what you've seen so far, what is the area or the application that's most exciting for you in terms of what graphene can bring right to the market? What's you personally the biggest disruption or the most exciting thing to be working on today on graphene?
Again, I can talk many ways. So my background's very much aerospace. So for me, been involved in aerospace for most of my industrial career. And a key drive in aerospace is today, going back to sustainability, is green aircraft. So for me, one of the stories I like to talk about in the early days when I joined, we actually coated a graphene composite wing with graphene, and then we made a graphene enhanced wing. Why would we do that? What might our planes look like in the future? Not only can we put graphene into the carbon fiber to use less material, to make them lighter, to make them longer range, less fuel, less noise. If we could also de-ice the wing of the aircraft, when you're going through clouds or when you're sitting in an airport, in the ice, if you could now de-ice by moving the heat around the wing Again, you could take out more weight, less fuel. Also, lightning strike protection. So currently wings have copper embedded in them to stop them from cracking if you get struck by lightning. Again, through graphene, potentially you could do that. So the exciting things is when you start exploring the multifunctional properties of graphene. So mechanical strength, thermal management, electrical conductivity, really get excited with airflow over the wing. Could I make that airflow create energy, which I then store in my wing? So as my aircraft's flying, it's generating energy to keep it flying. So that multifunctionality starts to get really exciting as an opportunity. And if you think of a sector like aerospace, not only could you get more greener aircraft using less fuel, less noise, longer range, it really could start to transform the way we use our transport in the future. So for me, it's just one example of the potential for graphene, but I think we need to keep our feet grounded. Nearer term, it's going back to earlier, let's get some simple things. But as we develop going forward, graphene and 2D materials has real potential to transform sectors like aerospace. So that's a great example. The water example is another one. If we could provide water to the mass population, that could transform lives, it could transform nations, and be really just make a difference in the world we live in. So lots of great examples where graphene and 2D materials can play a key role.
Sure. And I think going back to the more, say, industrial part of it, or the go-to-market strategies, how do you see really the companies who are working on graphene today? I think, what do you think is working well? What do you think has to be done differently? For example, a company like ourselves, or just launching ourselves into this market, what advice would you give us to tackle it the right way?
So for me, what we really need is not just the science, we need supply chain. So compliment Goodall, you're bringing in real, what I would call supply chain experience. And by that, that's manufacturing, it's engineering, it's understanding the customer, but it's also that whole mix of commercial, procurement, enabling activity you need as well. So for me to create a supply chain, we need to create the various bits. Not everyone does everything. Some people make graphene, but they don't know how to use that or how to mix that. So in a way, the geek is trying to be the catalyst, if you like, that helps bring that together. But we need companies like Goodall and your supply chain and your skills and expertise. Investment is also key. New materials are risky. Existing materials work. Existing materials are being manufactured, but we've got to also try and disrupt sometimes those supply chains with new materials and do things different. And sustainability is a good example of that. I mean, I'd maybe ask yourself, how you see your skills really complementing what we do, because we don't do what Goodall do. So I'd be interested on your view in terms of, particularly from a Brazilian perspective, what Goodall bring to ourselves as well in terms of a market.
For sure. I think it's very close to what you just mentioned. To us, it is, how do we make this real, really? How do we bring the science, right, from the laboratory to the daily use, right? How do we go to a marketplace anywhere and find with graphene, really? That's how really we make a disruption in the market. So it goes back to again, the supply chain, really, of having customer intimacy. I think really understanding what the customer needs. But I think at this stage we're at, I think beyond that, really, it's how to understand the customer's supply chain also. I think one of the big challenges we have in applying a new material to an existing industry is these customers have their machines, have their factories, they've had their investments, right? So they won't be so quick or so keen to change that, or change even a process that's working, right? And the daily operating rate, something new, right? No matter the value it has to be a fantastically huge value to really have that change, right? And only a few companies will still take that risk and be the first movers. So it's really, how do you understand what is the existing scenario, the assets and processes, and to really make sure that you bring something that is, let's say, as frictionless as possible, as plug and play as possible to the existing scenario. So there is some conversion work there of engineering the material as it is, the solution as it is, to really be adapted to the existing facilities, existing processes, right? So there is some conversion there. And the best person to do that, the best company to do that, is a company that has this DNA in the industry, right? It's hard to do this if you aren't used to working with large factories, large machines. So I think we bring that on board. I think it's We've been doing that for steel for many years, right? So we go all the way from the recycling of the scrap metal or the mining itself, to making that into the technology of the material in steel, but then also transferring steel into components for a client. So I think this last part is what we're looking to do with graphene, really, is how can we make it into something that's easily usable, right? That's the first, I think, thing. And the second one is also is I think, as you said, is helping educate the industry of how to use it, where to apply it, and then also investing in not only the R&D and capex to make that happen, but also the marketing and telling people the value there is in using the materials. I think that you have to have this, as you said, this conversion, the change of a mindset of going from a safe spot of using something that already exists to trying something new, and really being comfortable that that new has value, has benefits for you. So that goes from communicating the value, educating people on how to use it, and on the safety of using it, the value of using it, right? So I think that also comes from companies. They're used to doing investments in marketing and changing that in a more B2B and a B2C aspect. So I think that's really what we hope to bring aboard the industry, right?
No. Again, to compliment you, one of the challenges for everybody out there, what is graphene? There are so many different graphenes, and and again, I like Goodell's approach that you're talking to a number of the supply chain, because there's different graphenes for different applications, and I think that brings some seriousness, if you like, into the market, because again, for anyone who's new to this market, there can be confusion there.
Yeah.
But again, I think a systematic approach that you're taking is very complementary to pulling through the right graphenes for the right application.
Yeah, thank you. And it's one also challenge we want to overcome is exactly that. I think that the graphene means a lot and means very little. I mean, people think of it as something very simple, but at the same time, it really is a lot of different materials. A lot of different. Each material also can have a different properties. Also, right? I mean, lateral size, the purity, the number of layers, and so they can change a lot. So how you functionalize it also. So I think there's room for everybody. There's enough application work for different types of materials. And I think if you're a company focused on one production, you have to be very good at producing that kind of graphene at its quality, at its cost, at its scale. So of course that limits how much you can apply the material. What we're trying to do is look, as you mentioned, different applications for different types of materials, having some spillover of technology, right, from one market to the other. I think that will bring the whole material community to a more commercial length. Right? And there's room for everybody, I think, to navigate that. That's what we're trying to really do is bridge this gap. And
I mean, also, sorry, you mentioned recycling then, with the history of Goodell. How important do you see recycling, a circular economy going forward? Is that an area that Goodell Graphene are going to focus on, using recycled materials? Is that maybe a focus?
For sure. I think there's still, you might know this even more than I do, but I think there's still some groundwork on the science, the technology behind that, right? Still. But where you see several companies working with graphene from recycled sources, or graphene even from, say, biosources, right? So using, say, wood chips or different types of materials, which are, say, greener in a way, produce graphene. So it's for sure something we'll drive. It's in our nature to really focus on sustainable aspect of materials, and in recycling for sure. 7% of the metal we produce today is steel produced. It comes from recycling sources, right, from scrap metal. So definitely that is a key element for us. We are also looking at space. We're, I think, also trying to accelerate companies that are working with graphene from these sources. So we're excited to do what we can to also catalyze that technology change, right? But on the other hand, I still see this. It's still we don't see as much of a commercial graphene supply from these sources yet. I think it's something that we'll probably will hope to catalyze and see in the coming years, something at more and more pace, right?
Yeah, no, it's an exciting time, and I look back over the last 5-6 years, and the change in the supply chain of graphene production, and I'm sure if we go forward another 4 or 5 years again, we'll look back again and see a very different supply chain emerging around the different graphene oxide, CVD graphene. So again, for lots of different types of graphene for different products and applications.
And I think one thing that's really exciting for me of working with this material is that, as you mentioned, if you go back to like the key materials in history, right? So cement and concrete and plastics and steel, right? And silicon. These had very long cycles between when they were first invented or isolated until they were then become more commercial, until they actually became mainstream. If you you go back a couple of years, decades ago, plastic was not as readily available as it is today, right? So these cycles were long enough that it was very hard for us in a lifetime to see the whole change, or even more from myself in our work, right? To really through our careers be able to see the whole beginning to end to mainstream cycle. I think now things are much quicker, and graphene is really picking up. So I think really the exciting to me is as professionals, we can really be part of this change and see it from, as you said, from being born to really becoming industrial in terms of production, and then really becoming mainstream in terms of application. I think really that's.
You raised a key point earlier, and I think it's when they first invented carbon fiber, they had no manufacturing processes to use it, to process it into a product. I think generally on graphene, it is consistent with existing processes. So for rubber or for concrete, if I go to the concrete example, the work we've done is to mix using a standard batching plan. So it's not a new process, it's just a bag of additive that we put into the cement, same as any other additive that you might put into a cement. So if we can do that and approach it from an industrial mindset, and again, for me, that's what's different a little bit about the geek. Often a university approaches something from a scientific viewpoint. So we mix something or we add something in a laboratory that's based on making a few grams or a few tens of milliliters. And when we try and scale it, it's just not practical to repeat that or to scale that up. What we're trying to do with a geek is to do things at that pilot scale. So if we do something well, it's a lot easier to duplicate and replicate it in an industrial environment. And again, I think that's quite unique in academia around the world. You find pockets of it, in some areas, but as a general activity, that's quite a unique proposition, I believe, compared to many. Lots of academic institutes do great academic work, and I won't go into who's better or who's the greatest, but there's some great science taking place around the world. But the conversion of that science into products and applications is very variable, depending on organizations and countries around the world. And hopefully what we're doing in Manchester has some real value there for industry.
For sure, for us it definitely has. I think, as you mentioned, it's quite unique. I've been working with different materials in the past, and even if you go to other fields, we don't see this really. This melting pot of bringing the academia and the research and the science, but also with assets that can really make application work on existing machinery, existing processes that can really easily be scalable. I think that's really quite unique. For us, that's really why we see the geek as a foundation stone of all the application work we've been doing globally. So and of course, top of it all, you have all the community working together. So also a great spot to exchange, to really collaborate. I think that's really also unique. I think we talk a lot about open innovation, about collaboration and places where you can actually have networking and collaboration, but it's very hard to see it in practice, and even more in talking about something so innovative and as a new material, something so complex as application work in science, right? And we see all that at the Geek. So it's really, it's really what's driving us to really be excited of joining you 2 years ago and actively been working these past 2 years together. So we're really, really happy to be there and to work with you guys.
Where do you see the priorities for Godal? Can you say anything more around where you see those priorities in terms of application areas, or is that something that, I know we've talked, but maybe useful just to share if you're able?
Yeah, for sure. I think it's very similar to what you mentioned today. I think we before we launched the company, we looked at several different application potentials and really thinking what's the time to market to get that ready in terms of TRL, the application, also the development work on each kind of market, the potential size of the markets also, and how we would approach it commercially. And we're talking about basically 5 areas we would look into, and very similar to what you mentioned. So the first one is construction or additives in concrete. As you mentioned, I think that's the one that the market is closest to having something commercial and something ready available. So we are working on a system of solutions that we'll probably bring to market next year on that approach. So something we see some great potential in terms of volume and also disruption it can cause to the market. As a second, I think even a larger market would be a bit slower market is all the work we can do in polymers and basically plastics there and rubber. I think that you have it's a huge landscape, different types of applications from like screws and tires and conveyor belts and seals and packaging and films. So a lot of things that can happen. But again, we see this also the application work you mentioned is very how we can apply graphene is very aligned to the way the industry is working today. So it's very easy to do that. There's a lot of work already happening there. It's just really how do you make it scalable and really quickness again to supply master batches to different customers for different applications. It's a big second field of area we're working on, right? And then finally, we're looking a little bit also at coatings. So basically anti-abrasion coatings, anti-thermal coatings, something that will also be very well fit to our existing processes and factories. And then lubricant work also for industrial motors and all the automotive motors. So the huge trucking landscape in Brazil. So opportunities there in reducing fuel, reducing CO2 emissions, being more efficient, right? With the right lubricants with that theme. Very broad areas, but I think we really focus on initial solutions for each one of these areas. And for sure, we see work on concrete construction, let's say, and polymers as the beginning.
And say, I mean, they're all broad areas, but for me, great opportunity to improve performance, take cost out, okay. And we're starting to see some real going back to the Geek. We've now worked. Geek's been open just over 2 years now. So Goodell, one of our first tier 1 partners, but we've now delivered, in excess of 150 projects now. So some quite small projects, some bigger projects, but we're now starting to get a greater understanding of the graphene in those different types of products, some of the benefits. And again, going back to it, I think we'll start to see a real increase in pace now because going back to my excitement, we're not seeing a small benefit. We're actually seeing quite a big benefit, not in one area, but sometimes 2 areas or even 3 areas. So again, I think that will help with the commercial side of getting over the inertia or the risk of introducing a new material, because people can see some real benefits in the marketplace. I think will start to make the real difference.
Yeah, no, I definitely agree, and I think there's also a lot of again spillovers there. Of while you do an application in one area, the technology can be easily translated to a different area, and you can have a different benefit, a different and material performance gain. But again, the application technology is similar, has some hindsight from what you're doing somewhere else, right? And also it's all about having a whole portfolio of solutions. So when you talk about the construction market in Brazil, for example, which we have a lot of clients, we can go with different set of products from concrete additives to safety boots to different types of resins that can make a huge difference for them. It's different solutions, different portfolios again, but all of them have the power of really graphene performing a difference in terms of sustainability, in terms of performance to the customer. Right? So I think it's as we start getting these joint efforts really to the industry, it really will pick up things at quicker paces, I believe.
No, I agree.
And I think, and maybe as one of closing remarks is if I think for me it was very nice again last week to be with the PhD students really talking about how they see how their careers and how they see really this market. I think it's great to talk to the future thought leaders of our industry, right? So if you were to, since you're connected right to the Manchester University, if you were to talk back to these students, what do you recommend to them in terms of what's really, how should they approach new materials, how should they approach graphene? How would you invite them to join us in this mission, really making graphene a disruptor in the market?
I mean, for me, one of the objectives we've had, going back to Graphene City and the Geek, as well as the technology, as well as the industry, for me, a key, I call it deliverable, is talent, and that talent, graphene nanomaterials for many people can still be quite challenging. The story around sticky tape and graphite sounds quite fun. You can do it at home, but unless you've got an electron microscope, being honest, you probably don't know if you've got a single layer of graphene or not because you can't see it. So how do you really get excited about a material that you can't see, you can't touch, you can't, as a single atomic layer, it's quite impractical to use. But then when you start talking around some of the applications that we've talked around today, like water filters or aircraft or driverless lighter cars, electric cars, concrete buildings, Yeah, I think it starts to inspire, certainly not just the current, but in terms of future generations. I know my kids are more motivated by environmental. You know, we're not,
Yes.
we have glass milk bottles, not plastic. We're trying to remove plastic. We're trying to improve the environment. So I think, graphene 2D materials has the opportunity to inspire future generations of students, of school kids. One thing I'm quite passionate about is really around the whole STEM, science, technology, maths, engineering, maths type agenda. So how can we use graphene to inspire our future engineers, our future teachers, our future population, if you like. So the students are involved. One of the great things around Manchester, as a geek, as well as the corporations like Gerdau and Airbus and Rolls-Royce, GKN, who we work with, we also work with a whole series of startups and spin-outs, people who setting up their own business. They're one-man bands. They've never done business. I know Gerdau are working with some of them, which is really great. So if we can help also promote engineering, we can promote business startups. But it's not just about startups. If we can actually take those startups and make them into scale-ups. Mm-hmm. So by that, it's not a one-man band, it's a 10-man business or a 100-man business or even 1,000. If we can take them on that journey, I think people can then see a benefit, not only in terms of making a difference to society, water filters, environmental friendly, we can also hopefully create new business jobs and get more people involved in this whole area. So a key part of what we do is still the science, is still the teaching, is still the education. But if we can actually move the dial on the entrepreneurship, to create new businesses, new markets, new product, again, that's a key part of what we're trying to achieve. And for me, it's something that really excites me. We've got a number of those companies who are now in the geek. When you're over, I would like to introduce you to some of them, from people who are taking recycled tires to make a rubber mat, through to someone who's making a new graphitic hydrogel for growing food in vertical farming. So again, some really exciting technologies, but talent, students, people are really behind a lot of those ideas. And thank you for supporting the course last week. I think as well as hearing from science, what we try to do is to let them hear from real industrial people. And again, careful my language here, but we've had a few students who have come to the geek and they've really loved it, because they said, we had to deliver something to a schedule, to a time, to a customer, instead of just delivering my PhD. Now, careful, the PhD is very important, it's very big, but they generally got a lot of time, or have more time to deliver the PhD, whereas having a deadline or a real problem they're trying to solve can really make that science very relevant for what they're doing. So again, it's not just about the science, it's not just about the industry. If we can get those people working together, then for me, there's an opportunity for both people who want to do science as well as people who want to do engineering or jobs. That's really exciting.
For sure. And to me, the beauty is exactly there, is how to really have the science working together with the commercial aspect, right? The marketing, the having the product on the shelf. Really, I think that's the beauty of having, not losing the science and the drive of being innovative and trying something new and inventing and being curious, right? And having the investments there and in the researchers, in the startups, but also at the same time making sure that that's being channeled to becoming something real in the end, something that really will wind up in the shelf in someone's home, really, or in an industry, and will change that. Right? I think it's really the beauty, and it's not often you can do that, right? So I think it's something that's really exciting. I think the work you're doing at the Geek, and it's exciting. I think the work we're doing as a company. So it drives, I guess, the whole team here of really coming every day to the office and really find their best to make sure this will grow into a fantastic new material for everyone. So thank you again for all the support, and thank you for a great talk. It's been very great honor again to hear your opinions and your views on the market. I'm sure it'll change a lot of people have thought about graphene before this webinar. So thank you so much.
No, and thank you to Gerdau for being a great partner, and looking forward to really making a difference together. So thank you, and pleasure. Thank you today.